Hello dear students, I am Samir Velankar and I welcome all of you to this video in which we will see what do you mean by analysis of algorithm. By analysis, what we mean is we want to observe an algorithm and we want to know how much time will that algorithm take to complete its execution and how much memory will it take, how much memory will be needed to run this algorithm. Now, anybody asked which algorithm will you prefer to solve a problem, it's but natural that the answer would be I would prefer an algorithm which takes less time and the algorithm which requires less memory. Obviously, such an algorithm will be more efficient than an algorithm which takes larger amount of time to solve the problem. By the way, measuring the time taken by an algorithm is called time complexity. So time complexity, this particular term means how much amount of time will an algorithm consume to complete its work. Similarly, space complexity. Space complexity is nothing but amount of memory which will be needed to solve or to run that particular algorithm. An efficient algorithm, or rather a preferred algorithm by all of us, will be the one which has lower time complexity and lower space complexity. Just to give you an idea why this topic is so important for any computer engineer, why do you have to analyze an algorithm as far as time and memory is concerned? Let me give you an example. Suppose we have some problem that we want to solve using computer. Let's call this problem as problem X. Some problem, think of some problem, and we invite 5 programmers. 5 programmers are asked to write algorithm to solve this problem X. And 5 programmers come up with their own algorithms. Listen, we have not asked them to implement or write a program yet, but we just want their ideas, design strategies about how are they going to go about solving this problem X. So we need some stepwise description. So maybe the 5 programmers design their own algorithms, call them as algorithm A, algorithm B, up to algorithm E. Each of the programmers have designed their own algorithm, and we had very good programmers, and all the algorithms that were solved individually by them were correct. By correct, what I mean is this algorithm does what was intended. They give correct result. Now it is us to inspect that which of these 5 algorithms should be accepted finally. I repeat, all of them solve the given problem X. And we observe after analyzing the algorithm that this algorithm B written by person B is more efficient because it takes less time and less space, that is less memory, as compared to the other algorithms A to E. Obviously, we will throw away all these algorithms and we will accept this algorithm B and we will continue with its implementation. So we will now decide that we are going to write a computer program for this algorithm. Then which language, programming language, which platform shall we use for implementing this algorithm B? That's the importance when there are multiple algorithms, to solve the same problem, then we have to select the best one out of it, and the best one would be which has lower time complexity and lower space complexity. The only issue over here is how do you know that what is the time and space complexity? In fact, that's the entire topic for this particular subject. The subject of algorithm revolves around time and space complexity. But just to give you an idea, how do you measure this time complexity? Let us talk about time complexity. We have got one method called frequency count method. Very simple method, frequency count method. Okay. Now what this method says, suppose some algorithm is written, I'm just writing in an abstract way. Consider that there are many statements in the algorithm. Let's say this is the algorithm. written by A. This is algorithm A. Just as I pointed out above, 5 programmers have written their own algorithms, and this is the algorithm A to solve problem X. Now we want to know what is the time complexity of this algorithm. How much time will it take? Then the one of the methods is frequency count method. What we do is each of these statements, each of these operations, we count how many times these operations will execute. So let's say this statement executes only once. This statement executes again once. Now you might be surprised, come on, each statement will run exactly once, but that's not the case. There might be some loop somewhere in the algorithm. And maybe these 3 lines, which I am right now marking, execute repeatedly because there is a loop, and these 3 lines execute n times, let's say. Then this line executes n times, the next line also execute n times, and the next to next line also execute n times. And let's say this last line executes only once. Now we have a frequency over here, frequency, that how many times a particular statement executes, and we add all these frequencies. So 1 is there 3 times and n is there 3 times. So 3n plus 3 is the frequency count. So finally what we say is this algorithm written by person A will perform 3n plus 4 operations. Please check my words very carefully. There is no time. I am not saying that this algorithm will take 5 seconds, this algorithm will take n milliseconds. I am saying that this algorithm will perform 3n plus 4 operations. So what's big deal in this? You understand that as n grows larger and larger over here, the number of operations will increase linearly as a function of n, because this is nothing but 3n raised to 1 plus 4, isn't it? This is clearly a polynomial in n of degree 1. So suppose the value of n is just 1, then number of operations will be 7. But if the value of n is 1000, then the number of operations will be 3004. So what you understand is as n grows larger and larger, the number of operations will increase. Nothing special in that, because the polynomial itself is the function of n. So what is this n over here? This n is nothing but data size. This n can be size of the array. Maybe this algorithm is sorting the array and the size of the array is n. Now come on, if n increases and keeps on increasing, if we have a larger array, then number of operations will increase. Or this n can be size of a matrix, n by n matrix. Or can even be n can even be the number for which the problem is supposed to be solved, maybe prime number problem. So what we are doing is we are representing the number of operations in terms of n. Please try to understand. We don't say that time taken by an algorithm is so many seconds or so many milliseconds. We say time taken by an algorithm is the time taken by so many operations. Now just imagine algorithm writer B. There is another algorithm written, isn't it? Algorithm B has written an algorithm. Just say this is algorithm B written by the other person, and we count the frequency. Let's say this line runs once, this line also runs once, and there is a loop here where this line runs n times. Only this line runs n times and rest of the lines runs only once. In that case, the sum of the frequencies will be n plus 5. So number of operations performed by this algorithm is n plus 5, whereas the earlier algorithm performed 3n plus 3, isn't it? Now we come to a conclusion that this second algorithm does lesser operations as compared to the first algorithm. So we would obviously predict that the second algorithm is better. What it means is by analyzing an algorithm, we are measuring amount of time, which is known as time complexity, amount of space, which we will see in the later videos, space complexity, and we want an algorithm which takes less time, less memory, and it is supposed to do what it is supposed to. It should be correct algorithm, isn't it? Who will accept an algorithm which takes less time and less space, but it is wrong, it gives wrong result? Now, in this video, I just introduced frequency count method. We will learn more about this in the later videos. Thank you very much.